Hello, I'm your host Grayson Brulte. Welcome to another episode of SAE Tomorrow Today, a show about emerging technology and trends in mobility with leaders and innovators who make it all happen. If the future of mobility is important to you, join an SAE committee. They need the engagement, and it's a great way to get involved and shape the future. If you're interested, see the show notes for exclusive content on SAE.org and ways to get involved. We hope you enjoyed this episode. On today's episode, we're absolutely honored to be joined by Jesse Snyder, CEO, CTO of Zev Station and chair of SAE's Wireless Charging Task Force. On this episode, Jesse will share insights from SAE standards about wireless power transfer of electric vehicles. Jesse, welcome to the podcast.
Thank you very much. Very honored to be here, and I very much appreciate the invite.
We're excited to have you here because wireless charging is the future, and as you eloquently say, it's what comes after the plug. That's a brilliant way to look at this. And wireless chargers is expanding from passenger car to heavy duty. I'm really curious, Jesse, how will heavy duty wireless charging work?
Just want to take a step back. The J2054 task force covers light duty and heavy duty. The standard is out and published for light duty, and we just published a TIR for heavy duty, the J2054-2, which is the first level. So they both work the same way. That you've got wireless charging is
like a transformer without an iron core. It has a primary or ground assembly and a secondary coil or vehicle assembly, and that is tuned with a capacitor to a specific frequency. And as long as the coil is either the same topology as SAE 2954 or proven out in a performance way, it can actually transfer power over an air gap with high efficiency.
You mentioned the standard. I'd say I have a Class 6 truck, a Class 8 truck, and something in between a box truck, for example. When you have the standard, that will work across all of those, so an individual operating an industrial logistics arm doesn't have to put 3 different versions of wireless charging in place?
Let me say that we're planning for application use. Like, so for trucks, they'll have one type of coil, and for buses may have another type of coil. So for each application, we're planning to have an interoperable coil, very much like light duty. With light duty, whether it's a small vehicle or a sport utility vehicle, there's an opportunity to charge.
Wow. Where will the power come to charge? Will these individuals in the industrial environment or a bus depot, will they have to put in microgrids? Will they have to get a bigger line from the transformer? Where will the power come from?
So wireless power transfer is just that, or wireless charging. It's charging over an air gap. So it's the same. The power source is exactly the same as DC fast charging. But a general rule with DC fast charging, as soon as you get over hundreds of kilowatts, you're going to have to start thinking about some storage, or if you can capture as well as renewables and things like that.
How will it be deployed in the field? Will it be built into the roads? Will it be built in on the depot? Will it be built into the ground of the depot where the vehicles go? How do you see it being actively deployed?
Differently. So the interesting thing is that there's a lot of demonstrations already around the world for heavy-duty buses. And in every instance for heavy-duty, it's always either flush to the ground or slightly below the ground. And this emerging technology dynamic, that's actually usually buried below the ground a few centimeters. Will
this go in new construction? Will this be retrofitted, or how will it eventually be installed?
In terms of construction, in terms of vehicles, these are mainly targeted towards new vehicles. But keep in mind that the light duty standard is very evolved, and the TIR for heavy duty, not everything is written, which means that it's anticipated that the automakers that are participating, the truck makers, I should say, that are participating, are going to put them into their new trucks. And we're making a standard on how to transfer power, so that's up to the automaker.
Do you eventually see perhaps a dedicated lane on the highway, an HOV lane, could become a charging lane if you use, let's give an example here, the Port of Long Beach, San Pedro, in Los Angeles to Fontana, which is a very known drayage route today. Perhaps there's an HOV lane that has charging there so you can meet the California goals for decarbonization?
That's being planned in a few locations for demonstration today. So state of Michigan just announced they're doing a demonstration. There's something over in Oslo. So it's absolutely possible to do that. And there is discussion right now under an inland port in Utah to do exactly that. And it's up to, California. Certainly there is a great opportunity for any sort of a repeated route for heavy duty vehicles, as you mentioned, like a port, to put in a lane.
Michigan, Norway, and Utah have a lot of things in common. One thing they have, it snows. They get snow there.
True.
What impact does the snow? Is it wowzers? We can't go today because there's snow on the ground. What's the impact?
There's issues with conductive charging, with icing and things like that. But one thing that's really cool about wireless charging or wireless power transfer is that snow and water don't affect the power transfer. So it can be buried underneath a foot of snow, and the vehicle could pull over and it'll transfer power. So that's another opportunity for autonomous vehicles and the like, and also human, normal vehicles under all weather to be able to transfer power.
How about lightning? Lightning is scary, and lightning doesn't really get along with this stuff. What's the impact?
Well, we can't help you with that. Certainly lightning is but lightning and any other, you want to make sure that you're in a safe environment. But no, these things are they're grounded on the ground assembly side, and vehicles are grounded as they are. So, from
a high level technical standpoint, how can the energy go through the water, through the snow, which is basically water? Well, how does that work without causing any harm to the vehicle or any harm to the passengers in that vehicle? So
there's been a lot of work done on safety from our task force, and how it's done is magnetic field. So it's the similar theory of inductance. Basically, when you take two coils together, whether it be in a transformer or wireless power transfer, you have two fields that are generated. One of them is from the power, and the other one is from the induced power. And how it's done safely is there's actually been a lot of work done to make sure that the magnetic field stays within and underneath the vehicle, so the passengers don't see it. And there's also measurements and requirements that are done in the standard that make sure that either during charging or anything else, that it never goes above what the levels of safety, which are in ICNIR. And there's also something interesting as well. We have detection. We have foreign object detection, meaning if there appear some keys on the ground or something metal. And we actually have living object detection, meaning if there's any motion underneath the vehicle, that sort of thing. There's options to detect and shut things down.
We don't have to worry about our little friend the squirrel getting electrocuted then.
So certainly we're not. The objective is there's detection for motion. We don't have a scroll test, but the idea is we've done that. But one thing, there's an SAE technical report done a few years ago that we tested with the FDA inside their laboratory, wireless power transfer with pacemakers. Certainly not in a person, but pacemakers to make sure that not only healthy people, or should I say people without medical devices, but also people with medical devices are safe. So there's a lot of work done to make sure that driving up and parking are safe, but even in the car, that everything is perfectly safe.
All this standard work happens in committees, individuals such as yourself. You volunteer your time to come together to work on a standard. When you're forming the committee, the early days, even before you get to day one of the official meeting, what are some of those early conversations like? Is a colleague of yours coming with one idea, you're coming with another idea, and then as you as chair, you have to kind of try and massage it all together into a nice pizza? Is that how that process starts?
So sometimes it's holistic, sometimes it's much more dynamic, but start the early days of wireless power transfer. There was a lot of competing technologies and a lot of competing ideas between automakers and the suppliers, and it's more than cat herding. It took a lot of debate, and not only that, we actually did testing inside of national laboratories, Idaho National Laboratory, TDK Laboratory, to prove out that the technology will meet the criteria and interoperable. So to answer your question, it's not as easy as saying in a simple way that we just debated things. We actually had to go out, find designs, test them, and prove to the committee that it works.
Do all the members of the committee work on the technical aspects of it, or are there other individuals that aren't necessarily technical but have a vision that are participating in it?
So, SAE is free to all, and it is a technical committee, but we have folks that are involved that are involved in strategy, strategy of powertrains. We also have Sometimes we have, as I mentioned, regulators that show up and want to know what's going on. But mainly it's a technical discussion with the objective of, safe, fast charging over wireless gap.
Will the SAE J2954 standard play any role as you start to scale this technology, since that standard has been scaled and widely adopted across the globe?
So glad you asked. So J2954-1 or by itself is the light duty standard, and it's been reaffirmed last year. There's a new update from 2022. And there are already commercial applications. Hyundai has the GV60. A few years ago, there was a demonstration from BMW and E530. And Tesla just announced actually that they're doing a wireless power transfer vehicle as well. So there's a lot of buzz around that light duty standard. And the heavy duty is what's being worked on right now. It's a guideline. And we're planning to do a testing trial with that J2054-2, the heavy duty, in the coming year.
If you look at history, when Tesla first shipped the Model S, it really, in my opinion, ushered in the electric vehicles industry of where we are today. They single-handedly drove up, made consumers that this is a cool vehicle. This is really cool. I want to drive electric, and that's what Tesla did. And they're a game changer. When they introduced wireless charging based on the SAE J2954 standard, does that change the game? Obviously, you have Hyundai with the GV60, but does that start to usher in all the other automakers where they don't want to be viewed from a market perspective playing catch up with Tesla? Oh, Tesla's doing this. We have to go in. Does that accelerate the adoption?
So certainly in standards, we have, my role with standards is to be agnostic of the automakers, but absolutely Tesla really changed the game for the auto world. And people in companies are still playing catch up, if you see. But I think that, we'd be excited. So the GV60 right now is released in Korea, South Korea. We understand that it's going to be coming to the States at some point. But yeah, absolutely. When Tesla did a teaser at their investor days about wireless charging, and certainly when that comes out, it'll be a big motivator for us all to get into the technology. Yeah.
And I know you can't answer this, but I'm going to say this from a marketing perspective. If and when Tesla opens their drive-in movie theater that they're advertising in the Los Angeles region, they put wireless charging in there, that's a great marketing way to drive the adoption of the standard.
Absolutely. So if you're sticking around for an hour or two, that's plenty of time to charge your vehicle. But that's a great opportunity, yeah.
Outside of Tesla, from a standards perspective, will all vehicles be able to use the wireless charging system if the vehicle they own or driving has the technology incorporated into it?
That's the intent, absolutely. So one thing that's cool, so conductive world has a number of standards, with charging. There's CHAdeMO, there's Tesla, there's SAE. We spent a long time working with other standards organizations from ISO, IEC, and GB to make sure that there's one standard. So that means if you pull up to a ground assembly for light duty ground assembly, whatever, as long as you're SAE, you'll be compatible and you'll transfer power.
Standards allow scalability. If you have 3 or 4 or 5 different standards, it's not going to be scalable, and then you're going to have a very mad consumer. Well, why won't this work? It says I have inductive charging. Why doesn't this work? And so hopefully that drives it to one standard. So you have the individual that's buying the vehicle, the GV60, for example, or if the Tesla does the wireless charging at some point, they're coming from the factory. They're built with the wireless charging into them. How about the individual that has an older vehicle or perhaps a model year 22, 23, says, this is really great. I bought an electric vehicle. At some point, will they be able to retrofit their vehicles? And if so, will it meet the standard?
Yeah, so, we don't design for aftermarket. We just design the wireless charging. But I can tell you that there is already a company that is, in fact, a few examples of electric vehicles like the Mach-E or the Tesla that have been retrofitted. So it is absolutely possible. And as long as they follow the standard, everything should work.
When the individual, they're on their way home from work and they're pulling into their garage or they're pulling into their parking spot at their residence, are they going to have to neatly maneuver? Okay, we've got to be right there. And then perhaps when they're in the garage, they hang a tennis ball to make sure, they put some paint down to make sure they're in the right area? Or is it going to be, okay, you can just pull in your garage and away we charge, similar to today?
Yeah, to answer your question, certainly there's an alignment tolerance. It's much better than pure inductance, but the SAE allows for 4 inches each direction and gives you also communications to your vehicle on alignment direction. So you're going to get feedback while you're driving. And also there's at least one development where you can actually get automated driving integrated as well.
How great's that? You pull into your garage and say, okay, car, park, and then it does it for you. That seems that's where we're going. And if you look at, on the other side, autonomy, now suddenly you're scalable. You can eliminate what Cruise GM has, the robotic arms. You can allow autonomy to scale with wireless charging. Do you see autonomous vehicles being one of the key drivers of this technology?
The only way to really charge vehicles autonomously under all weather is with wireless charging. So certainly you can have a robotic arm, but you still have these same shortfalls of conductive charging with regards to ice and snow, things like that. But we think that it will help, and already is talk between automakers as well, with driverless taxis and things like that you can just put a pad in a place that it can charge and come back to every night.
And the beauty about this is, if you have the depot manager on the commercial side, and perhaps somebody calls in sick, you don't have to worry about plugging in it. But on the personal vehicle owned side, we're going on a road trip. Oh, I forgot to plug the car in last night. You don't have to worry about that. That becomes a game changer there.
It is, so in terms of, we think of, if you think of wireless charging as changing the game, it does, because all you have to do is look for the green light when you park, make sure things are charging and walk away. And it's transparent. And then when, that you could bring that to workforce charging and other places. But yeah, the idea is it automates the process completely. All you have to do is make sure that the process is started.
Can it support two-way power? Perhaps you can run your coffee maker off it, or if you had a hurricane or you lost power, you need to, let's just say, got to do laundry. Everybody has to do it. Perhaps you can run your laundry machine.
There's V2 grids, V2G is something that is in the conductive world, and we intend to add that also to wireless charging. There's already been some demonstrations from Honda on doing that. It's very possible. So that will be added to the future standard. Yes. I don't think it's specifically for an appliance like a coffee maker, but it's actually V2G, vehicle to grid.
Yeah. Just trying to give practical real world examples. You mentioned add to a future standard. Is a standard a living, breathing document where if there's a new breakthrough in technology, the committee gets together and say adds point 2, or if you want to use the ABC acronym, is it a living, breathing document that updates?
It definitely is. So we're to a standard level in light duty, I mentioned, and guideline for heavy duty, moving to recommended practice. But so there's new things that are coming in. One of them is new alignment methodologies, for instance, and those will be added to the standard in the year. So absolutely, as new technologies come in, the standards adapt.
I play video games, so I have to ask put in this sense. Is it backwards compatible? If I have a vehicle that meets, let's say, standard 1 and then standard 2 comes, am I still backwards compatible there, or do I have to upgrade?
The document, we called it forwards compatible. So, but the document that we put out in as a standard for 2054 is worldwide meant to be compatible. Since there's not a production vehicle out, since the production vehicles are coming now, you can't speak about backwards compatibility. But the good news for automakers, it gives that confidence that when you say the word standard, it can be adopted into a local code and turned into law. And how do you, so it's really a powerful tool that helps start commercialization, to give that confidence of what's coming down the pipeline.
Commercialization is good for the economy. It makes the world run rounds. We're commercializing the tech. We have the standard that's looking to the future and adapting as technology changes. What does the maintenance look like? How is this going to be able to be kept up in charge? Do you have to have somebody inspect it every day from a commercial aspect, or in your home you look at it, or what does the maintenance look like?
There is no maintenance planned. It's solid state. So there's standards that have been done on the safety side, from the UL standpoint, from the SAE standpoint, to make sure that it meets all the requirements of any sort of appliance or device. But there's no maintenance planned for it. Certainly if there's some damage to it, it needs to be repaired maybe, but it's not a schedule.
Yeah, your current business, your CEO and CTO of ZevStation, you got a big focus on electric charging and hydrogen fueling stations. Way to go on the hydrogen. That's going to play a very large role here. Do you see wireless charging as the natural expansion of the Zev business of where you're going?
Sure. Well, I'll just to put my other hat on, in terms of the startup that I that I lead. So ZevStation is a small startup. We have an office in Palm Springs, California. We have also some DC charging that's going on right now, and a fleet with FedEx ground ISPs. And we plan to expand to hydrogen as well. And we've made some announcements with Chart Industries. You may have heard they're the largest industrial supplier for for equipment for natural gas and also hydrogen. So wireless charging is, because it's not yet mainstream, but we see it as definitely for an opportunity, especially when you think about truck stops where you have not necessarily fast charging, but when you have trucks that are staying overnight, for instance, there's a really great opportunity, or parking for dinner and that sort of thing, to expand that. You can imagine trucks pulling up to certainly they can do fast charging and DC fast charging, but there's a real big gap for electrification. What happens with trucks that have refrigerated trucks in the back that run all the time, and also what happens with trucks that stay overnight? Are you going to go when you come in and then charge again when you go out? And how do you bring those big cords out to a parking lot with trucks? So that's the answer to that. That's where we believe things are going to be heading. But that's, kind of the play after the next play.
If you look at a truck stop, think about the amount of carbon that can be saved if they have the wireless charging from idle time. These individuals that are sleeping in their truck and they're running them to stay warmer, to power their appliances. This is a really great solution. They're not going to lose range. They're going to be able to do their job really, really well. And they're going to cut down on carbon. This seems as almost the perfect solution. You don't have the cords running all around the yard.
Right, exactly. We see that as being an opportunity, another market, so to speak. Certainly there will be high power charging, and there's megawatt charging, things like that. That's planned. But wireless charging is something where you can place in a specific spot, especially where those, there are actually laws that are anti-idling, is what you mentioned, right? So it's a really big opportunity to help in that market as well.
The one thing about trucking, there's a lot of divide. Is it going to be electric trucks or hydrogen trucks? The bottom line is, in my opinion, hydrogen is going to play a very large role, especially in long haul over the road, like a Covenant, the expeditors going cross country. Zev has a hydrogen strategy. What is your hydrogen strategy?
If you think about gasoline and diesel, we see charging really being taken over taking over the gasoline, right? And there's this last Friday, the California Air Resources Board just approved the ZEV mandate for trucking, really saying the expiration date as well for heavy duty. We have light duty that was also is also a law. But what we see right now is light duty, medium duty going charging, and heavy duty split between the long haul and the short haul. And the long haul we think is going to go hydrogen because it's 7 tons more battery. And it's simple math in terms of between the two technologies. One shift operation for heavy duty can certainly stay charging, but there's an intersection between an electric truck and a hydrogen truck, and that is where they park at night. And so that's where I see, as the technology we're talking about today, wireless charging being an assistance to both of those markets.
At the end of the day, they complement each other. I could see electrification working on drayage runs and long haul over the road working on hydrogen. When we have long haul over the road working on hydrogen, we're going to need fueling stations. ZEV is working on that. How are you planning to deploy hydrogen fueling solutions?
So our intent is to make, so certainly we have our first station, for charging. We're looking to expand upon that. And our intention is to be off the highway in rural charging and capture, cars and trucks off major interstate trucking routes. And we've pulled up next to a large fleet owner, FedEx, for instance. And we think that having a location next to a fleet makes a lot of sense off the highway as well to get the public traffic.
You want that. will you partner with a hydrogen provider? Will you store it, or are you going to build the technology, or what role were you going to play in this?
No, so this discussion was about SAE, but certainly I'll mention that ZEV Station is planning, as I mentioned, the equipment from Chart Industries, and we already have a relationship with a large liquid hydrogen supplier. That's not yet public, but certainly the idea is if you're going to do a rollout of stations with a lot of hydrogen on board, really liquid hydrogen is the way to go. Certainly for smaller stations inside the city, you can do gaseous hydrogen, but as soon as you go with trucking, there's no other way of doing things because it's many tons of hydrogen.
You're clearly down the road, no pun intended. You're working on the SAE Committee on Wireless Charging. Your business is working to commercialize wireless charging, and you have a hydrogen strategy to complementing it. What role do you see ZEV playing in this? Do you want to become, no pun intended, the de facto standard in how fleets and individuals decarbonize? Is that where you're ultimately trying to go?
We are a startup. We want to be part of the equation. And our objective is, I worked, as you know, in the automotive industry, over 25 years. And I came to the realization everyone is building a ZEV vehicle. But who's building the ZEV station? And that question ringed for many years, and that was the purpose. So we are a B corporation. We're environmentally motivated. And our objective is to have zero carbon sourced fuel for all the ZEVs on the highway. So we would like to be part of the reason why we're going to meet net zero. And that's a pure play. And certainly others will be retrofitting gas stations or, that sort of thing. And that's part of it. But the idea for us right now is really to help with this new electrification push. I mentioned the ZEV mandate that's coming. We see this as the other side of the equation that needs to happen.
It's a bold plan. It's a bold move, and you're backing up with a B Corp. You're a B Corp. You're putting your money where your mouth is.
Yes.
You're developing this. You're rolling up your sleeves. Wireless charging is merely just, I'm going to use a baseball analogy, it's merely in the first inning of where this technology is going to go and get adopted in scale. In your opinion, Jesse, what is the future of wireless charging?
It's multifaceted. So it's, and this is to keep in mind, there's many different use cases, but I think that there's an opportunity for taxis and airport taxis and things like that to do wireless charging. And as they're creeping to waiting for customers and things like that, there's an opportunity to charge as they come back. There's an opportunity for single shift, operations of trucks, for instance, or you mentioned drainage or somewhere where there's a route that they constantly go to. And certainly this overnight charging, it can't be avoided. I really think that it's not addressed now, but I really think that that's coming down the pipeline to help decarbonize really all zero-emission vehicles.
If an individual's sitting here listening to this podcast and says, wireless charging's cool, I work at an auto company, I want to roll my sleeves up, can they get involved in the SAE 2954 committee? And if so, what do they have to do? Do they send you a note? How does it work?
So Dante Radar is the SAE representative for the committee, or for the task force, I should say. And definitely contact him with the email provided. And it's free and it's open for all. And we really would encourage it, especially if you're in the automotive industry, also in the supplier industry, the infrastructure industry, and you'd like to get involved in this technology, join the team, join 2954 task force.
Roll up your sleeves. For the listeners, we'll put a link in the show notes, and if you don't remember the link, you can always go to sae.org and search it. Jesse, this has been a fascinating conversation around the future of wireless charging and the role standards are playing. We can't forget about the important role that hydrogen is going to play in decarbonizing as well. And as we look to wrap up this conversation, what would you like our listeners to take away with them today?
Just first, I want to very much appreciate the invitation, and I'd like to mention that wireless charging is really a technology that's coming. And, if we are to meet our objectives to get to net zero, it's a cliche. It's not a silver bullet. There'll be applications where there's going to be conductive charging. There's going to be applications where there's going to be hydrogen. But there's also a look at applications, especially with autonomous vehicles, that wireless charging is going to play. So that's really where I'd like to leave as a message.
As Jesse said there, and he said throughout this podcast, wireless charging will play a very big role in the future. Today is tomorrow. Tomorrow is today. The future is wireless charging. Jesse, thank you so much for coming on SAE Tomorrow Today.
Thank you very much.
Thank you for listening to SAE Tomorrow Today. If you've enjoyed this episode and would like to hear more, please kindly rate, review, and let us know what topics you'd like for us to explore next. Be sure to join us next week as we speak with Nexar's co-founder and CEO, who will share the company's computer vision solution to the dilemma of real-time mapping.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.